When calculating the answer to exercise 13 on page 279, you should follow the steps that I'll show to you right now. Basically, the question says that we're doing a titration with the EDTA complex to decide how much calcium and or magnesium ions are present in the water. Now we're told that our water sample is 250 millilitres and it's titrated against a solution containing 0.0113 mole per litre EDTA. Now, we're also then told that 18.4 millilitres of this solution was needed to react with all of the calcium and magnesium ions present in the water sample. So the first thing we need to do is work out, well, how much EDTA is present in 18.4 mils, because we know from our reading of theory that EDTA reacts at a 1-to-1 ratio with any magnesium and calcium ions present. So if I can work out how many moles were in 18.4 mils, that will tell me how many moles of calcium and magnesium must have been present in 250 mils. So how do I do that? Well, the number of moles is equal to the concentration times the volume. Now I know my concentration, it's 0.0113 mole per litre, and my volume is 0.0184 litres. Remember, you must always express the volume in litres to keep it in a common term with the concentration. Now if you put that into your calculator, you can express that then as 2.07 times 10 to the negative 4 mole, and we'll say it now, EDTA in 18.4 mils. That's how many moles are actually there. So therefore, that's how many moles of calcium and magnesium are actually in 250 mils. However, I need to find out how many moles of magnesium and calcium are actually present in a whole litre. Therefore, I need to rearrange my formula. Concentration, you know, is equal to the number of moles you have divided by the volume in litres. So therefore, the number of moles of magnesium and calcium ions in my water sample is equal to the number of moles that are there. Oh, sorry, the concentration. I should be saying concentration, sorry. The number of moles that are there divided by the volume in litres. There it is, in litres. And if you put that into your calculator, you'd be told, well, that concentration would be 8.32 times 10 to the negative 4 mole per litre. So that's telling me that my sample, according to the titration, contains a concentration of magnesium and calcium ions of 8.32 times 10 to the negative 4 moles per litre calcium or magnesium ions. The next step is to use that molar number in reference to calcium carbonate, which is how we express hardness. So we say, therefore, I want to know, well, what mass of calcium carbonate would I have if I had that many moles? Now, mass is equal to the number of moles you have, 8.32 times 10 to the negative 4, times the molar mass of a compound. Now, calcium carbonate's molar mass is 100.1 grams per mole. Now, if you put that into your calculator, you'll find out that that would weigh 0.083 grams. How many grams? 0.083 in what volume? A litre. Now, hardness is expressed in milligrams per litre, so we need to move by 1,000 or a 1,000th. So if I had 0.083 grams, I would have, move this way, 83 milligrams per litre, and you know that that's 83 ppm because ppm is synonymous with milligrams per litre. Therefore, hardness of this water is either of those two values. It's sufficient to express it as 83 milligrams per litre or 83 ppm. You need to recognise both. Now that's your answer, and that's correct. And the question then says, why is it not necessary to determine magnesium and calcium ions separately? It's simply because we know that the calcium ion or the magnesium ion reacts with the EDTA complex in a 1-to-1 ratio. Now if that's true, no matter whether they were all magnesium or all calcium, or half and half, or 60-40, whatever it may be, all of them would have reacted with EDTA at a 1-to-1 ratio, giving us this value here in moles per litre. That value there is always then expressed in terms of calcium carbonate, which is the given way of expressing hardness. So therefore, it's unnecessary to decide which ones were magnesium and which ones were calcium, unless we've accounted for them all. As long as we've accounted for them all as EDTA does, then we can go and express it in milligrams per litre according to the molar mass of calcium carbonate. You should have been able to do that quite easily, and that's a classic example of the kind of question you'll get in your HSC.